While the rest of the world was captivated by flashy electric vehicle unveilings and media fuel battles over specs and price points, a quiet revolution was unfolding inside Tesla's engineering labs. Hidden from the spotlight, away from product announcements and tweet storms, a team of Tesla's top engineers was working on something that could change the very foundation of electric mobility. This wasn't a mere upgrade. This wasn't just about optimizing efficiency or shaving tenths of a second off acceleration times. It was a radical reimagining of one of the most critical components in any EV, the motor itself. And this redesign, this breakthrough, was so significant that some insiders have described it as akin to discovering a piece of future technology smuggled into our present day. What Tesla has created is not just a motor, it's a declaration of intent, a signal that, while others iterate, Tesla is redefining the rules. The company's new carbon-wrapped motor represents one of the most consequential leaps in EV engineering in recent memory. It's not just fast. It's efficient, durable, scalable, and smart. It's not just the heart of a car. It's the engine of an ecosystem. Let's break it down. For over a century, the internal combustion engine ruled the roads. When electric vehicles entered the scene, they didn't reinvent everything. They repurposed existing ideas for a new context. One of those ideas was the use of heavy metal rotors in motors, usually composed of steel or copper. These rotors were reliable and well understood, but they carried significant limitations. As electric motors spin faster to deliver more power, metal components heat up, sometimes dangerously. That heat leads to expansion, deformation, and eventually degradation. Even high-performance EV motors top out around 16,000 RPM because, past that threshold, stability and durability become serious concerns. Try to go faster, and the system begins to shake itself apart. This created a dilemma. If electric vehicles were to compete with or outperform combustion engines, not just in acceleration, but in longevity, reliability, and cost, they needed a different approach. And that's where Tesla's carbon-wrapped rotor comes into play. Carbon-wrapped rotors, a quantum leap. The secret to Tesla's breakthrough lies in its use of carbon fiber, a material better known for its role in aerospace and Formula One racing. It's ultralight, incredibly strong, and more importantly, highly resistant to heat. By wrapping the rotor in carbon fiber, Tesla didn't just tweak the motor, they redefined what it could be. This innovation allows the motor to reach and maintain rotational speeds of over 20,000 RPM, with some testing environments pushing the limits even further. Unlike traditional designs, this rotor doesn't warp, overheat, or lose efficiency under stress. It thrives in conditions that would cripple conventional setups. And what does that mean on the road? Blistering acceleration. We're talking about 0 to 60 miles per hour in roughly 2 seconds. Performance numbers that rival the world's most elite hypercars. But this isn't just about speed. The true genius lies in how that power is delivered. Instantly, smoothly, and consistently, without thermal degradation. A new benchmark in efficiency. Speed is flashy. Efficiency is foundational. The carbon-wrapped motor doesn't just offer performance. It delivers performance with a fraction of the energy cost. Because the rotor is significantly lighter and more heat-resistant, it requires less power to generate motion. That means less battery drain for the same, or better, output. This reduces reliance on heavy cooling systems, which are a staple of high-performance vehicles. Those systems add weight, cost, and complexity. By minimizing thermal output at the motor level, Tesla eliminates the need for extensive cooling, trimming down both manufacturing and operational burdens. Less heat, less weight, less drag on the battery. All this translates to more range, faster charging, and longer battery life. It's a triple win. Strategic timing. Tesla's market response. Tesla's reveal of this new motor couldn't have come at a more crucial time. By early 2025, Chinese EV giant BYD had surpassed Tesla in global electric vehicle sales volume. BYD's strategy of producing a wide variety of affordable EVs for emerging and domestic markets helped it capture large market segments that Tesla hadn't fully penetrated. Meanwhile, legacy automakers like Ford, GM, Volkswagen, and Toyota were pouring billions into their EV transition. Many of them repurposed combustion engine platforms, retrofitting them with electric drivetrains and hybrid technologies in an attempt to stay relevant. Others like Lucid and Rivian emerged as luxury disruptors, showcasing futuristic tech, but struggling with scale and cost control. In this intensely competitive environment, some speculated that Tesla's dominance was beginning to waver. The narrative shifted. Was Tesla peaking? Were they being outpaced by more agile or aggressive players? But the carbon-wrapped motor flipped the script. It wasn't just a technical triumph. It was a strategic masterstroke. While other companies scrambled to iterate and adapt, Tesla had built something completely new from scratch, specifically for an electric future. Not a reaction, but a reinvention. The battery connection. Enter the 4,680 cells. Tesla's innovation doesn't stop at the motor. Their advancements in battery technology are just as game-changing, particularly the introduction of their 4,680 battery cells. These cylindrical cells are larger, more energy-dense, and structurally integrated into the vehicle chassis. This design reduces internal resistance, enabling faster charging and discharging. More importantly, it allows Tesla vehicles to maintain peak performance for longer durations without overheating or depleting the battery rapidly. The synergy between the carbon-wrapped motor and the 4,680 cells is where the magic truly happens. Together, they create a high-performance powertrain that's lightweight, energy-efficient, and incredibly durable. Each component is optimized not just individually, but in how it interacts with the whole. This kind of vertical integration, controlling everything from battery chemistry to motor design, gives Tesla an advantage no other car company can match right now. AI and software, Tesla's invisible engine. Tesla's edge isn't just in hardware, it's in intelligence. While other automakers are chasing self-driving dreams with complex LiDAR systems and heavily pre-mapped routes, Tesla is building a vision-based AI that learns like a human. Using only cameras, each Tesla vehicle acts as a mobile sensor array, feeding real-world data back to Tesla's neural network. This data is processed by Tesla's powerful Dojo supercomputer, which trains its full self-driving FSD models on everything from unpredictable road conditions to pedestrian behavior. The result? An autonomous system that's constantly learning, constantly updating, and constantly improving, even when your car is parked. This AI also manages motor performance, battery usage, energy conservation, and climate control, adapting in real time to maximize efficiency and comfort. It's not just self-driving, it's self-optimizing, manufacturing, building a smarter factory. Where others see factories, Tesla sees an engineering problem. Traditional automakers are weighed down by legacy infrastructure, assembly lines designed for combustion engines, sprawling supplier networks, and multi-tiered dealership systems. Tesla threw out the rulebook. Their gigafactories are purpose-built for electric vehicles. These aren't just production plants. They're vertically integrated hubs that handle everything from raw material processing to final assembly. Techniques like single-piece castings reduce complexity and cost while improving structural integrity. Key processes like battery and motor manufacturing are brought in-house or embedded directly within the Gigafactory ecosystem. This allows Tesla to move faster, cut costs, and maintain higher quality control. Add to this their direct-to-consumer sales model, which completely bypasses dealerships. And you have a closed-loop system that's faster, smarter, and leaner than anything legacy automakers can currently replicate. The bigger picture, building the operating system for the future. When you zoom out, the carbon-wrapped motor is more than a technological leap. It's a foundational block in a much larger vision. Tesla isn't just making cars. They're building an ecosystem. Solar roofs to generate clean energy, power walls to store it, superchargers to distribute it, AI to manage it, vehicles that not only transport people and goods, but interact with homes, cities, and power grids in a fully integrated loop. Imagine a future where your car charges itself using solar energy from your roof, where your home battery system balances energy loads during peak hours, where your vehicle learns, adapts, and updates itself while you sleep. This isn't science fiction. It's the infrastructure Tesla is actively building one component at a time. A new era begins. So, while headlines may focus on BYD sales figures or the next SUV launch from a legacy brand, Tesla's carbon-wrapped motor marks something far more important. The start of a new era, a phase where electric vehicles aren't just an alternative. They're a superior platform in almost every measurable way. And this motor? It's just the beginning. A demonstration of what's possible when you stop chasing the market and start reshaping it. Tesla isn't just participating in the EV race. With every innovation, be it in motors, batteries, AI, or manufacturing, they're redefining the course of the entire industry. The carbon wrap motor is more than a component, it's a statement.